So to find this constant of proportionality, you reduce the ratio comparing quantities by doing the division. Remember, a ratio can be written as a fraction, and a fraction is just a division waiting to happen. So it's the same way you find unit rates, but in this case it's going to be how we use the answer and what we interpret it to mean that's going to be a little bit different. So example 1. At the grocery store, 4 kilograms of bananas cost $3.92. Determine the constant of proportionality and use this to determine the cost of 3.2 kilograms of bananas. Previously, we would have set up two proportions that were equal to each other, put an x in for the unknown costs, and solved using cross multiplication. Now we're going to see how using the proportionality constant gives us a new way to solve these types of problems. So we are given 4 kilograms of bananas cost $3.92. We're going to write this information as a fraction. So $3.92 divided by or over 4 kilograms. We're going to divide the numerator by the denominator, and we get 98 cents or 0.98 of a dollar per kilogram. This is the constant of proportionality. It costs 0.98 of a dollar per kilogram. So now, given that that's our constant of proportionality, if we want to figure out how much it costs for 3.2 kilograms, we simply multiply the constant of proportionality by the given value, 3.2. So 98 cents or 0.98 of a dollar per kilogram times 3.2 kilograms equals $0.98 over kilograms times 3.2 kilograms over 1. And when we do this, 0.98 times 3.2, we get $3.136, but we're going to round to the nearest hundredth because it's money. So because following the 3 is a 6, that tells us to take the 3 and round up to a 4. And we've carried units here in the kilograms, and because we have a kilogram on top and a kilogram on bottom, it cancels out. You're going to see lots more these types of unit calculations in science and if you move on to physics, but we show it here so we know we have kilograms on the bottom, but we're multiplying by kilograms on the top, so all we're going to be left with is the dollars or the cost, which is what we're looking for. So it costs $3.14 to buy 3.2 kilograms of bananas. So it would not be wrong to write it as a proportion as kilograms per cost. So we did cost per kilograms here. We could do kilograms per cost. In that case, you would have to divide 3.2 kilograms by the constant of proportionality. So if we choose to do it in the other order, because remember we've talked about this before, that order is important, but it's more important that you're consistent. So if you chose to do it this way, especially because we see the 4 kilograms first, we're going to get a different constant of proportionality. It says that it's 1.02 kilograms per $1. So now we have a different constant of proportionality. That is 1.02 kilograms per dollar. If you can buy 1.02 kilograms for $1, how much is it going to cost to buy 3.2 kilograms? So this time we have to divide. We have to take the 3.2 and divide it into chunks of 1.02 to figure out how many dollars it will cost us, because each 1.02 chunk costs $1. So 3.2 kilograms divided by 1.02 kilograms per dollar equals approximately $3.14, the same answer that we got before. So it still costs $3.14 for the 3.2 kilograms of bananas. So the order you set up the fraction to find your constant of proportionality isn't as important as when you figure out that order, knowing whether you're going to multiply or divide to solve the given problem. So we did arrive at the same answer, both were correct, but the most common expression is dollars per kilogram. How much does it cost per kilogram? So a lot of the times people will default to that no matter what order the information is given, because we're used to dollars per kilogram.